All right, let's work on going the other direction. Let's see if we can start with some information and work back towards the equation for our line. So first set of information for part A is that our line has a slope of 7 and passes through 0, -2. And this is really particularly nice information because 0, -2 is a y-intercept. So we are very nicely set up to use y = mx plus b slope-intercept form, and we can just fill in the blanks. So slope-intercept form needs 7 filled in where the m is, and the y value of the y-coordinate, -2, filled in where the b is. And that's really all you need. So this is easiest possible scenario. It can get a little trickier if you're not given your y-intercept, if you're given some other point, but we'll look at that in the next example. Okay, so next example is giving us 2 points, which is just a single step off from having a slope and a point, because we can immediately go ahead and calculate our slope. So we're given y2 minus y1. So I'm choosing 0.1 and 0.2 in this order. You can absolutely flip-flop those. You just have to be consistent. So it has to be y is on the top, x is on the bottom. And as soon as we put the -7 first, the 2 has to go first on the bottom. We got a little bit of mess with our negative signs. Okay, so we get -12 on the top and +6 on the bottom, which is a slope of -2. So that's rather nice. Now we can look at this as we have a slope and a point. We have 2 points, so we can choose either one. So I'll just use this first one. Doesn't really matter which one. Given a slope and a point, you can use either point slope form or slope intercept form. Point slope form is maybe a little bit easier as you just fill in the Point slope form is maybe a little bit easier to just fill in the blanks, but it's only a very little bit easier. And if you're only going to remember one form, remember slope intercept form. You can use it for everything. So let's do point slope form first, and then we'll work on the other one. Point slope form says you take y minus the y value of 1 point on the line, so we'll use 5, and that equals your slope times x minus the x coordinate of that same point, which is -4. So this will become a +4. So y minus 5 equals -2x minus 8. And then if we distribute, we get, I'm sorry, we just did distribute. If we add the 5, we get -2x minus 3. So that was just adding 5 to both sides of the equation. And that would be my answer. So even if you use point slope form, you'll want to write your answer in slope intercept form. But let's go through really quickly how this would look if we wanted to use slope intercept form from the beginning. So we would still do this first step. We would still calculate a slope, which would put the slope intercept form like that. We don't know the b yet, we do know the m. If we want to find the b, we would pick either 0.1 or 0.2 and just plug it in for x and y. So what's true always is that if the point is on the line, it makes the equation true, which means we can absolutely validly say when we plug a 5 in for y and a -4 in for x, that is a valid statement, so we can solve it for b. And if we multiply and then subtract 8 from both sides, we get that our b is equal to -3. So we would just carry down our -2x that we've already figured out, and we would replace b with -3. And that is the exact same answer. So whatever is your favorite, go for it. I actually tend to favor just using slope intercept form in algebra, but when we get to calculus, we do this whole chunk of finding the equation for tangent lines, and it gets really handy to just go ahead and use point slope form to get you started and have only like 2 steps to do to solve that. So really doesn't matter, but that's why I show you both of them. Okay, last quick thing is what if we're given the graph of the line? Sometimes this is easier, especially if you can just read off exactly what your slope and your y-intercept are, then it becomes very much like part A. This one is a little trickier because I can't see what my slope and my intercept are. I'm sorry, I can see what my slope is. I can't see what my intercept is. So this is closer to part B. It's more like the 2 points. Okay, so let's look for some nice points. And do be careful about this. For example, this wouldn't be a great choice because I'm going to have to estimate what my y value is. I don't know if that's negative 5.2 or 3 or 4 or something in between. So always look for points that hit right on grid lines if possible. For example, right here appears to hit exactly on 3, negative 10. And then I would say this one as well looks like it hits exactly on 6, negative 8. And this one even would be a good choice. So pick a pair of points that look like they fall on exact coordinates if possible. It's not always possible, but if it is, use it. From here, you could definitely go back to your slope formula and use y2 minus y1 over x2 minus x1. But you can also just do this visually on the graph as long as you count carefully. Oh, excuse my jump. So right here, it looks to me like I went over 3, delta x is 3, and I went up 2, delta y is 2. And both are positive. It is to the right and up, so do pay attention to sign. That's the one thing I think people mess up when they just try and count it out instead of using formulas. So it looks like I have a slope of 2/3. And then again, you could actually count backwards to find your y-intercept, but let's just go through it as if that wasn't necessarily so easy because sometimes it won't line up with a nice point. So if we're not sure, we just follow the procedure we just did up above and we say, okay, let's use a point. I'm going to use 3, negative 10. Feel free to use 6, negative 8 or whatever you would like. And I'm going to say y minus negative 10 equals m 2/3 times x minus 3. And again, I'm totally happy if you want to use slope-intercept form to do this. Roughly the same amount of work, whatever you're more comfortable with. So I'm going to say y plus 10 equals 2/3 x minus 2/3 times 3 is just 2. And then we'd need to subtract 10 from both sides. So minus 2 minus 10 is negative 12, which does seem quite reasonable. If we followed our slope back, we would go down another 2 to go right 3. So that looks perfect with what I'm seeing on the graph. Okay, so given either a point and a slope or 2 points, you should be able to find the equation for a line.